Hi everyone, my name is Jared Lubert and I am a digital forensics specialist with Belkasoft. Today I will be discussing SQLite forensics. First, we'll start with the why. Why should we be familiar with SQLite databases? And why is SQLite forensics important? Well, first of all, almost all applications store information in SQLite. You can name almost all third-party chat applications, for example, Skype, WhatsApp, Telegram, Facebook Messenger, all major browsers such as Chrome, Firefox, Edge, and others all store information in SQLite. Even some popular mail folders store their data in SQLite databases. So why is SQLite so popular? Well, it's a lightweight database that does not require installation. You simply create a database and you can begin using it. And that's why developers love it. Unlike Microsoft SQL Server or some other databases that require various services to be running and require an installation of libraries on your system for it to function appropriately, SQLite does not require these items for it to work. Now, it can store a lot of data inside, but still lacks some features of big database engines like SQL Server or Oracle. But many applications do not need these features, and say mobile applications that don't have enough resources or power because most mobile phones are not as powerful as typical computer. SQLite is a database of choice because it does not require a lot of resources. So that is why when performing forensic examinations, you will commonly encounter many SQLite databases. Of course, there are a number of tools, including tools from the creators of SQLite, but a non-forensic tool will not show you some interesting aspects inside of SQLite databases, and it will not use those particularities of this database engine. So, what are some of the consequences of using a non-forensic tool for analysis of SQLite? Well, there may be many of them. You can miss some or even all of the data stored within the database. You can spoil the data inside of the database, as non-forensic tools will not complete transactions within the database and will lose some of the data from either journal file or write-ahead log files. So, this is not what you want to happen in the course of a forensic investigation. With that being said, here's the course of action for the webinar today. Some particular items of interest and things to know regarding SQLite databases include how it stores information, what a free list, journal file, and write-ahead log is, as well as what unallocated space is inside of a SQLite database, and how to carve from a SQLite database. I will also show you some of the examples of working with SQLite in memory capture of a running computer. First, we will start with pages. Data is stored in a set of pages of the same size. This size is specified when an application that stores the data in SQLite creates the database. Typically, it goes by the power of 2, such as 1024 to 4096 bytes per page. And after the database is created, the application cannot change the size of these pages. If we're speaking about just reading data from a database, this is fairly easy to do. The forensic tool you're using simply uses an API, which is provided by a SQLite engine. There are many tools which can do that, such as DB Browser or plugins for Firefox that allow you to read a SQLite database as well. However, the interesting portions of reading a SQLite database start when you're going to try to recover some sort of data from deleted areas or other areas of SQLite. So now we're going to dive into a free list. So what is a free list? Well, I told you that there was data that is stored in a set of pages. Well, there's a special kind of page that's called a free list. In these terms, SQLite kind of works like a traditional magnetic hard drive. When you delete something from a hard drive, you know the data is not deleted immediately. It's just marked for deletion. This is kind of the same concept with SQLite when you delete something in a SQLite database. It's not deleted automatically. It's just sent to a special page known as a free list. The free lists are there for performance reasons because if you delete something immediately, you would need to reorganize or remap the data inside the database, copy the deleted data to the tail of the database, and then cut the database. This requires a lot of effort from the application engine and will take some time. So in order to save this time, free lists were introduced so data is not immediately deleted and just marked as deleted. So if you can somehow access free list pages, you can see recently deleted records. Now these records are kept within the SQLite database, unless the page is allocated for new data, which have came from the SQLite database as a new record. So, does every SQLite database have a free list? The answer to that question would be no. This feature is a parameter of the database and a parameter called AutoVacuum. Free lists will only be present in SQLite databases if the AutoVacuum feature is set to 0 or 2. If this feature is set to 0, that means that the AutoVacuum will not start. The AutoVacuum feature is the process of real deletion of deleted items. If the AutoVacuum configuration is set to 1, that means full AutoVacuum, which in turn means real-time deletion of artifacts. As mentioned previously, when real-time deletion takes place, a reorganization of the database must also take place, and it implies performance penalties because every deletion operation will require this reorganization. So, a quick recap. If the AutoVacuum parameter is set to 0, there is no AutoVacuum configured and a free list will exist. If this configuration is set to 1, this is full AutoVacuum mode, meaning there is no free list and data is immediately deleted. Now, there is one more option, and this last option is where a configuration may be set to 2, which is an incremental AutoVacuum, and a free list will exist, but with limitations. With this configuration set to 2 is more in a manual AutoVacuum state. So AutoVacuum makes database fragmentation worse, and that is why it is switched off in most databases, and why most developers do not employ a full AutoVacuum by default. But this is good for us as forensic examiners because we'll likely have the opportunity to recover data from these free lists. So again, an additional recap here. Free lists are features of SQLite database. It is a regular page with SQLite that contains recently deleted data, and these pages will not be visible to standard API. So if you read database content with the help of SQLite standard libraries, you will not have access to these free lists. So this is why you need a good tool for forensic investigation of SQLite data. So now we'll see how it works inside of Belkasoft Evidence Center X with our built-in SQLite Viewer. So let me find a SQLite database, which, by the way, can be loaded into Belkasoft without loading a case. We'll simply browse our File Explorer for a database file that we want to examine and open it inside of Belkasoft X. Okay, so now that we are loaded into Belkasoft X, we will select our Messages table. And from here, you can see a record type labeled Free List. Now, the width of each of these columns can be moved around to your liking. It's just like an Excel document. However, another really cool feature inside of the Belkasoft X SQLite Viewer is being able to convert unreadable timestamps to human readable. So we right-click on the column, choose column type, and select what version of timestamp we want to convert the time to. And then also one thing we can do is right-click on columns and choose columns, and you can pick and choose what you actually want displayed in front of you inside of this built-in viewer. Now, we're going to see The structure of the database can be flipped between data and structure there at the top. And then we're going to look at how many records we have. Looks like we have found 59 deleted messages here inside of this database. So now let me open the same database in DB Browser. I will go to Browse Database, Table, Messages, and you can see here that we have 0 items. So if you use DB Browser for SQLite, which is a great tool that allows you to execute SQLite queries against the data and manipulate and put together information pertinent to your investigation, you should think twice before using it for forensic investigations. This particular tool lacks support for deleted data within SQLite databases, so you may be missing that pertinent information. So the next interesting concept of SQLite is journal files. These were used before version 3.70 of SQLite, but still used by some applications. And this particular file helps SQLite maintain database integrity. So when you write new data to SQLite, the application and the code can roll back the attempt to write the data, and this is where a journal file helps to accomplish this. So first, imagine you have a database file with 4 pages. Here in the picture on the screen, we can see that the journal file is empty. Then a new record goes into the database file, and page 3 is updated during this operation. Now, the old page should be remembered in order to perform a rollback in the case that's necessary. So, old page number 3 goes into the journal file, a file kept in the same folder as the database file and is usually named something db-journal. So if the code is required to roll back, this will override the new page number 3. Additionally, if a commit takes place, for an example, an application closes, the journal file is flashed and is completely gone. So as in there is no more old page 3. So now the stable database is overwritten with the new page 3. And one way you can remember this is people write into a journal so that they can remember something that had happened. And so that is how a journal file works. It stores the old content in the journal file until it is either rolled back and put back into the main database file, or it is committed to the main database file and the old file is then flashed from the journal file. So what does this mean for a forensic investigator? It means that at some point when commits have not yet happened, you may have 2 versions of page 3, an older and a newer version. Both of these pages may be important and, in some cases, can really make a difference to an investigation. Again, you have to use a forensic tool to see both options, to see both the new and the old versions of page 3, because a regular database browsing tool will just skip the older page 3 and not display this data. So now we're going to dive back into Belkasoft X and show an example of what a journal file might look like accompanying a regular database. Alright, so before we begin inside of Belkasoft X, what I'm going to start with is going to be showing you what a journal file might look like accompanying a main SQLite database. And so I'll open up an example here in my File Explorer. Alright, so the main SQLite database is going to be our msn.db that we can see here on the screen. And obviously our journal file is going to be the one labeled db-journal. So this is what it's going to look like in File Explorer. But as I mentioned before, it's very important that this is opened up in a forensic tool. Again, SQLite browser, such as DB browser, will not treat these database files in an effective way for a forensic investigation. So there's a couple things that can happen if you open these up in non-forensic tools. So one, if your media is writable, you're going to alter the evidence. You can see these records in your tool, but your entire results may not be accepted. So the main SQLite database file will be changed. Its hash value will not match the original. And so this file will then disappear from the media. The second thing that can happen, if it's not writable, a commit will not happen. It means the data will not get into the main database file and therefore will not be shown in your product. And you will not see any of that uncommitted data. So either way, both of these options are not good for a forensic investigation. So there are even some digital forensic software tools that may use standard SQLite drivers, meaning that you can have the same experience with the same consequences that I just talked about. It's important to note that Belkasoft X does support low-level parsing for both journal files and WAL files, which we will get into right after journal files. But it does this without attempting to alter any data, meaning that we will not alter evidence at the same time, ensuring maximum results. All right, so now what we're going to do is jump into Belkasoft X. And as an idea of what we might do to process an artifact to see the SQLite database, I'm going to go to the dashboard, and I already have a few data sources already loaded, but I'm going to show you how we would go about adding a data source to Belkasoft X in order to find these SQLite database files. So I would go add data source, add existing if I've already acquired the image and I'm wanting to load it into Belkasoft. For this instance, I'm going to choose image. I'll browse to my testing images, go to BitLocker. And you can see I have an E01 loaded here. Again, I've already got this loaded into the product, but I'm just showing you the steps of what this looks like. So I'll go ahead and select that. The first thing it's going to say is, hey, this is encrypted with BitLocker. Please enter the password in order to decrypt this. So what I'm going to do is type my password. It's going to apply, and once it is supplied, then you can see that it's no longer encrypted for the processing purposes. And from here I'll select next. Now what we can do here is this is where we have the option to carve any sort of data from our image. So it recognizes this as an NTFS volume. You can pick where you want to carve. So we can do archive files. So if any sort of compressed files are important to you, I would highly recommend selecting this. You can choose to do no carving, carve all space, or to carve free space. And I'm going to skip this for now, just know that is an option. Again, it automatically recognizes this unallocated space as well, so you can carve that. We'll select next, and this is where we would like to select specific types of artifacts. Now for the sake of this demonstration here, I'm just going to say, hey, just select all artifacts, because I don't know exactly what it is that I want to see inside of this file. So I'll select next. From here, go through the process of whether or not I want to do hash and so on. I can also do a match for a hash set database. I can do picture analysis. I'm going to skip this for now. And then select next. And finally, it would ask us if we want to create a profile or not. We'll say no. It lets us see our options, and then we'll select complete. So I'm not going to do this because, again, I've already got it loaded. But that is how you would process that image. Now you can see this drug trafficking E01. This is what we actually just set up the processing for. What we see here is the drug trafficking case.E01 in gray with a white data source appended to it. Now these are found inside of the E01, and they're known as nested data sources. So that is what that would look like. So let's jump into our artifacts now. And what I'll do is I'll browse down to chats just so I can find a SQLite database. And we'll start with this top one here. So this is Viber. And what I can do for the SQLite database is either select it down here at the bottom of the screen where I can look at my SQLite database from this location, or I can pop it out to a full screen. So let's go ahead and do that. And when we pop it out, we can see that we have some journal file entries inside of the SQLite database. So as I mentioned before, if I were to open this inside of a non-forensic tool, we would not be seeing these journal entries. Now, if we look down here at the bottom, it says there's a total of 34 items inside of the messages table of our Viber Messages SQLite database. So 34 items, and of those 34 items, we have 17 journal records. That is roughly 50% of what is inside of this database was found in journal files. So just letting you know how important those are. You're missing roughly 50% of your evidence if you're trying to do SQLite analysis in a non-forensic tool. So another thing that we can do, say this is a bit noisy for us, we can right-click, choose columns, and this will allow you to pick and choose what columns you want inside of your SQLite database. So I'm not going to change anything, just wanted to show you that that was an option. Now, what is really interesting is see that this is a date time stamp. So instead of looking at this non-human readable date time stamp, what I'm going to do is right-click, choose column type, and change it to Unix time UTC. And that's going to change this into a human readable time. All right, so with that being said, we have our data tab. This is what's going to allow us to actually look at the contents of these SQLite databases. But we also have the structure. The structure will allow you to see additional information regarding the SQLite database. Now, I don't want to spoil it, but you can also see that there's unallocated space found within this SQLite database. So after we talk about write-ahead logs, we will dive into the unallocated space. So the next portion of SQLite that we'll be covering is the write-ahead log, or WAL file. This is almost the same as the journal file in the fact that it is also a secondary database file that is used to maintain the integrity of the original database. WAL files are employed by SQLite after version 3.7.0. So what is the difference between a journal file and a write-ahead log? So looking at the picture on our slide, we can see that we start with those same 4 pages and the write-ahead log is empty. At the second stage, we see a new page that goes into the database file, and instead of going directly to the main database where old page 3 is stored, it goes to the write-ahead log. So now the write-ahead log, or WAL file, contains new page 3, and old page 3 is marked obsolete and is ignored by the main database engine. So when you try to read the database file from page 3, the engine will automatically go to the WAL file because it knows old page 3 is no longer in use. Finally, when the data is committed to the main database from the write-ahead log file, all changes are resent back to the main database file, and the new page 3 that was in the WAL file is now ignored by the database engine. Again, as with journal files, at some point, we will have 2 versions of page 3, which are older and newer. But with write-ahead logs, they are reversed. The new page is stored in the secondary database file, and the old page is stored in the primary database. So I was talking about the journal file, mentioning that we wanted to remember something that had happened in the fact that we could revert. And so in the write-ahead log, we're committing to the write-ahead log before we actually commit to the main database. So it's just a reverse sequence from journal files to write-ahead logs, but they perform the same function in maintaining the integrity of that database. So it's yet again important to remember that non-forensic tools will not show a fair amount of data from SQLite databases. So we're going to get back into Belkasoft X, browse to our SQLite Viewer, show another example here of what write-ahead log records look like inside of our forensic SQLite Viewer. Alright, so we're back inside Belkasoft Evidence Center X. And remember that we can load SQLite database files into the product without having a case loaded or a data source loaded into the product. So I'll open up my hamburger up here in the top left-hand corner. I will select my SQLite Viewer, and from here I can browse to a database that has a wall file. So I am inside a testing images SQLite and a locations D folder, and here you can see there's a db-wall. This is our write-ahead log, and you can see it's got a pretty significant amount of data in it. So just to show you how this works, I'm going to select the actual database file itself and select open into Belkasoft X. Now if I were going to open this in a non-forensic viewer, the consequences would be that it would try to write the data in the write-ahead log to the original database, altering your evidence. But you'll see here when I open this up inside of Belkasoft, it's not going to change that. So you can see I've just opened it. I'll open that Explorer back up. We'll open up location, and you can see that nothing has changed for the files. So now that we're back in the SQLite database viewer, I want to start by talking about this properties pane at the top of your SQLite database. Now this property is going to tell you the page size. It's going to tell you how many pages are in this particular database, and then also how many free list pages. So you remember those are items that have been marked for deletion that are still a part of the database file. And of course, the journal type here is a write-ahead log. Now you'll remember that the journal type changes after SQLite version 3.7.0. So this is obviously a slightly newer SQLite database than what we were just looking at with our journal files. So as an example here, if I were to look at the cell location, you can see that these are part of those 2 pages of free list that were found in this database file. And if I scroll down to, let's say, the Wi-Fi tile headers, this is where we're going to find our write-ahead logs. So write-ahead logs inside of Belkasoft Evidence Center X will appear as purple record types. And again, if we look down here at the bottom, it says that there are a total of 1,003 records inside of this particular table. And of those 1,003 records, 954 of these were found from a write-ahead log. So again, extremely large amounts of information that you could be missing if not looking at these databases in a forensic viewer. One thing that I didn't talk about before getting into Belkasoft X is how long data can stay in these write-ahead logs. So data can actually remain in a wall file for a very long time. That changes either when the page is full or it hits a checkpoint, and they can be the same thing. But until then, the database will read data from the write-ahead log instead of using the main database file. So the checkpoint event occurs automatically after the wall reaches a certain size. Now by default, this is 1,000 pages. Changes can be committed via the database API or manually with a SQL command, which is actually pragma wall _ checkpoint, and that will commit a checkpoint for the write-ahead log. So for many different types of artifacts, 1,000 records are a lot. An entire chat session may never trigger a single checkpoint. A few days of browsing may not even force the checkpoint event. So this means that for a few days, weeks, or even longer, the information in the write-ahead log will remain uncommitted. So it's important to know during a forensic investigation, if you're not seeing something inside of the main database, just know there are these supporting files, write-ahead logs, free list, journal files that can all be used in conjunction to show you the full story behind your SQLite database. So remember that I said SQLite is kind of like a good old magnetic hard drive because data is not deleted immediately, and you know that hard drives have unallocated space. And SQLite can also have this unallocated space. However, It's a little bit of a different concept. Now, you can see here on the slide a typical SQLite page. First, we will have our pointers to real data inside of the page, and then data goes from the end of the page to the beginning of the page. So all cells or records between that pointer and the data is data that is somehow not addressed by the SQLite database. And this is called unallocated space. Because of using free list pages, which contain previously deleted data, this unallocated space, in some cases, can be trash and rubbish data, but it can also hold some meaningful data as well. And this is why we are interested in what is inside the unallocated space, especially if this is a large SQLite database file. This is what it may look like inside of Belkasoft. And here you can see that some records have been recovered from this unallocated space. A lot of this data is junk, but there is some human readable items inside of this unallocated space that Belkasoft X was able to carve. Now, we didn't add any specific file signatures for carving, which, by the way, we can load FTK and scalpel file signatures into Belkasoft X for additional carving. You can also create your own carving signatures with a header, footer, and file extension in the settings pane of Belkasoft X. But as you can see here, again, there is some useful data. Now, let's jump back to a different artifact inside Belkasoft X, one that's already loaded in from a case, and see if we can find some additional meaningful data inside of an unallocated space of a SQLite database. And of course, just as with all the other special SQLite files, non-forensic tools completely ignore unallocated space in SQLite databases. So what is carving? Carving is a searching mechanism that utilizes signatures to identify artifacts within raw data. You can perform carving of SQLite database using Belkasoft X or any forensic tool with SQLite capabilities. The reason that we're bringing up carving for SQLite is that there can be many issues when it comes to carving SQLite databases. SQLite version 3 has a very good strong header for carving, but it does not have a standard footer nor a predetermined length in its header. So you either have to cut it at 5 or 10 megabytes, or you have to do some intellectual calculations of length of the database files. With Belkasoft X, we try to estimate the size of the SQLite database based on in-house research that we have completed. So before we dive into memory analysis, we're going to jump back into Belkasoft, add a data source where we can attempt to carve SQLite databases from a system image. Alright, so I'm going to go through the process again of adding that BitLocker encrypted image just to kind of show you, again, what it looks like to try to carve or process a system image for a SQLite database. So let's go back to add data source, add existing, image, go to our BitLocker image. We'll enter in our password again. Select next. Again, we can do carving to try to carve the space. Also, you can just come over here in the filter bar and begin typing SQLite, select an artifact, and then you can do only process for SQLite databases. So you can analyze the carved and embedded data as well. So what we would do is, before going through these steps, is one, if we had signatures that we wanted to carve for, we could go add those in our settings pane. So we'll jump back a little bit. Just to remember that this is where you would come to process specifically for SQLite databases and go through that process. Now, let's go and into our home screen, into our settings tab. We will go into carving. And from here, we can import file signatures. So we have FTK file signatures and scalpel that can be ingested into Belkasoft Evidence Center X. We also have where we can add our own signatures. So we can name it, put a header, a footer, and a file extension as I just previously mentioned. The final talking point will be analyzing memory for SQLite databases. First, we have a free tool for capturing both 32 and 64-bit systems for Windows memory images, which is called Belkasoft Live RAM Capture. So, why should we perform analysis of memory for SQLite databases? The reason is you have a fair chance of finding many SQLite databases. Typically, though, it's not an entire database that's committed to memory. However, there is normally a signature of the beginning of the database and a couple of tables loaded into memory. Also, there's a large chance to see corrupted or incomplete SQLite databases, which means that even if you were able to somehow save a SQLite database from memory to disk and open that database in DB Browser or a Firefox plugin, you'll possibly mostly just notice that it says, hey, this is a corrupt file, or this is not a valid SQLite database. Now, this is important to use a tool that allows you to view incomplete database files. Here, you can at least see the structure of the database and maybe even the first few kilobytes of some of the database tables. All right, so we're going to jump again back into Belkasoft. We're going to load a memory image data source. And here we're only interested in SQLite databases, so we're going to leave everything else default. Alright, so we're going to scroll down to a memory image that we've processed, where we specifically selected SQLite database files from the artifact processing. And so they're not just showing up as SQLite databases in here, they're under other files. And so what we're going to do is, well, obviously we can see these are SQLite databases. So there's a lot of other files that were processed out. So if we were to select some of these, we can see that there's no tables or any sort of unallocated space or anything that was, extracted from the SQLite database. So if we were to open this up, there'd be nothing there. Now, obviously, in the header, it says something about 5 free list pages. But what we want to do is just kind of look through some of these. And for instance, this one that is open right here looks like it has a little bit of data in it. So if we open this up to full screen and select some of the artifacts here, it's not a whole lot of information. But if we were to go into unallocated space, remember I mentioned that a lot of databases may be found in a memory capture, but a lot of it will probably be rubbish. But potentially we can find something in this raw data that may be useful for our investigation. So let's jump over to the raw data portion. And so right off the beginning here, I can see that there is some information that's human readable. So if we were to scroll through some of this, we may find something of interest to our investigation. So all that to say, it's very important that you know that you can extract SQLite databases from memory images to try to capture, maybe a nugget that would not be available in a standard investigation. So that will wrap up the content for this webinar, and we will now perform a recap of what we have covered: how the data is organized, a set of pages of a fixed size. Then we covered FreeList, which is a page in SQLite that can potentially be used to recover recently deleted data. We then covered journal files and write-ahead logs, which are used to maintain the integrity of the main database files, and how to recover additional data from these secondary databases that will eventually disappear after a commit to the main database. So again, at some point, 2 versions of a database may exist. Using a tool like Belkasoft X will allow you to get the maximum amount of data from these SQLite database files, both primary and secondary. We then covered SQLite unallocated space, which is not to be confused with hard drive unallocated space, where data can fall between pointers and records and can possibly contain trails of recently deleted data because the unallocated space may be taken from a free list page. Finally, we briefly touched on the use of carving from images, both system and memory, and analyzing our carved databases within a forensic browser, such as Belkasoft X. So that is it for today. If you are interested in trying Belkasoft Evidence Center X, you can request a free trial at www.belkasoft.com/get. Out of the box, supports close to 1,600 different types of artifacts, allows for both high and low level analysis with our connection graph viewers, picture analysis, and recent integration of Volatility 3 for memory analysis. Then finally here, please follow us on social media. Our Twitter handle is @Belkasoft. Facebook is www.facebook.com/Belkasoft. And LinkedIn, we can be found at Belkasoft as well. And then finally, our website is www.belkasoft.com. Thank you for joining us today, and happy hunting.